Hello, this is Bill checking in with homework number 33 on Paul McWhorter's POW class. Um, the assignment is a continuation of stuff that we've done, so I'm only going to hit the changes in this, but we had a weather app, and Paul wanted us to change uh, whatever the temperature was to a color. And he kind of went through an explanation showing the HSV to RGB conversion and color wheel and that kind of stuff. So, I first started kind of looking at this thinking, well, that kind of is like a sine wave. And maybe it's just a sine wave that's, shifting, has interval shifting for the red, blue, and green. And I dinked around with that. And, well, what I really did was I got online and found a calculator that does that. And no, Paul was 100% right. And the way he was doing it. So I figured I need to stick with that. And you can see that the LED's going, and it's kind of an orangey type color, and that's still showing the barometer. That should flip to the next one, but it is, I can't read that from here, 58 or something degrees. Yeah, 58.75 degrees. So pretty basically, I've got this page up to show you the RGB, and I had this set up before, and I actually had it set up for PMW, although I didn't use it. We're going to be doing some mixing, obviously, on this one, so yeah, we are going to have to use the PWM. So this is how we do that for the red, green, and blue. Set it up with the frequency, and the duty cycle here is just 0, and we will change the duty cycle. That's the mixing part of that. Let me go down to like line 150. So this is my next thing that's showing some calculations, but let me show you how I got there first. This is going to be kind of goofy because I'm just going to hand hold this camera, but these probably look familiar. That's what Paul was drawing. So I'll just kind of take one and go through it. From here we've got 360 degrees, and here we have the 255. So this is the HSV, or it's weird, I learned it as HSL, but anyways, HSV to PMW. So you can see, right here and here where it's full blast, and right here where it's nothing. So I just kind of made those notifications, or not, I just noted these are the conditions where the RGB is 225 is full blast, and these are the conditions where it is 0. And I did the same thing for blue, and I won't go through every number. You can kind of see what I'm looking at there. And then for green, okay, then since we were trying to take the temperature here, and we needed to convert that to HSV. So let's go down to the next thing on here. I always draw these, it just makes it easier for me. So the HSV goes from 0 degrees to 360 degrees. And I picked the temperature for here. I guess I could widen that and it would include everything, go from, minus 20 to 120 degrees Fahrenheit. I just picked the scale from 20 degrees Fahrenheit to 100 degrees Fahrenheit, and that'll get, 99% of the days that we'll get. But anyways, so that's the graph, and it's a negative slope, and the slope is minus 4.5. You can see I got it that way. And then here's we haven't done this in a while. Paul likes these. Okay, there's, the line slope deal. So we did y2 minus y1 equals the slope minus x2 minus x1. x2 is actually the temperature. Y2 is HSV. And then we can plug in the y1 and the x1 values, and that is that's the equation that I get to convert from temperature to HSV. So the temperature will be that what is it, weather, then brackets main, brackets temp, I think is what it is, in order to get that plus 360. So that's one equation we need. Now, since on these things I did the full blast and nothing, we need to figure out the slopes. So come down here, and again, I always draw these, but here, this is a red slope, and they're all going to be the same slope, whether it'll just be positive or negative, because all these go from a 60 degree span, from 0 to 120 is 60, and I can't read my writing. Oh, 240 to 300. So you can see all those are going to be 60, and this is all going to be from 0 to 255. Okay, so here it is. I calculated the slope. This is odd. I'm watching it through the screen to make sure I stay on and not the paper. So, but anyways, there's the slope, and the same thing that we did up there. So the red RBG minus y1 equals the slope times HSV minus x1. Just plug in x1 and y1, do the math, and that's the equation that I get for the negative slope of red. And we do the same thing. Here's the positive slope. This one, I did this one first. This one, I'm just going from 0 across. Same thing. There's my work. Kind of hold it there for a second so you guys can see it. But essentially, you can see there's my equation for that slope. Then I do the same thing with positive and negative slopes of the blue. You can again see doing the positive slope first and the negative slope second. Just moving along from 0 to 360 essentially. Sorry, making a mess. Okay, so that's the same thing, and you can see there's the equation I got for the positive slope, there's the equation I got for the negative slope. You can see there's my work and the points, what I got. Same deal with the green. You know, we're doing the same stuff over and over again. So here's the slope of the positive slope equation for the green RGB, and here's the negative slope for the green RGB. Okay, so I went and did that, and unfortunately this guy, the LED was just very, very dim, and it took me a while to figure out what the heck was going on. It was working, but it was just very dim. And then I stumbled on, oh, well, this is what I need to do. We need to convert the RGB to PMW. So you can see the PMW goes from 0 to 65,535, and the RGB goes from 0 to 225. There's my slope, which is 257, and the math comes out easy because we've got 0 and 0 for both the X1, Y1 type thing. So we essentially get PMW equals 257 times the RGB. Let me do that left-handed there. Okay, get that other one. So that's all the work we did, and I know Paul really likes that stuff. So let me put this back, and yeah, okay, so here's where we calculated the HSV from temperature. So that's weather, main, temperature. So this is grabbing the temperature, and this is the equation that I have for it. And so we just do that, and that prints out HSV. And the HSV is going to be the same for all the colors because it's that, you know, the temperature is not going to change and the scale doesn't change. So that's what that's what we've got. Then yeah, okay, so we're coming down here. This is the mixing colors. Let me go back a little bit. This was the conditions for 255 for full blast RGB. This is, you know, the flat line for 0 RGB. So I just had those two. Then I threw in the conditions for where the negative slope is. Went from 60 to 120 degrees. Like I said, all of them are 60. And there was an equation that I have for the line that I showed you earlier on my notes. And here's the conditions for the positive slope. Same thing, ditto, ditto, ditto. Oh, back up a little bit. In order to get it to the PMW side of stuff, all we needed to do was take excuse me. All we needed to do was take the red RGB and multiply it times the slope of 257. So I just tacked that on to the end of each one, just because it was quick. And then here was some stuff that I printed out just to test stuff. I can probably get rid of the sleep. I was wondering if I was doing something goofy with, I threw in a sleep thing thinking maybe it's going so fast, that's why the color's dim, but that wasn't anything to do with anything. So that's my homework, and it seems to be working, so I got this one out a little quick. See you next Tuesday. Bye-bye.